Guys, welcome to my another video, and in this tutorial we'll learn about Coulomb's law. Before that, please don't forget to subscribe and like my channel. Okay guys, if you have done subscribing, let's start. So what Coulomb's law says, okay, so suppose if this is Q1, which is positively charged, and if this is Q2, okay, not this Q1, this Q2, which is negative charge. Now if we increase the charge, okay, if we increase the charge here, what will happen? The attractive force between these two charges will increase, right? Now in case 2, if this is okay Q1, and if this is Q2, but if their distance is increased, okay, if their distance is increased, what will happen? The attractive force, right? The attractive force between this Q1 and Q2 will decrease, right? This is what Coulomb's law is trying to say. So it's Coulomb's law is Coulomb's law is saying that if the charge, okay, Q1 and Q2 is increased, then the electrostatic force between them will increase, right? They are directly proportional. And if the distance r square, okay, if their distance between Q1 and Q2 is increased, then electrostatic force between this Q1 and Q2 will decrease, which is inversely proportional, right? This is what Coulomb's law is trying to say, okay? Let's see now. Okay, Coulomb's law, okay. So according to Coulomb's law, the magnitude of electrostatic force between 2-point charge is directly proportional to product of magnitude of two charge and inversely proportional to square of distance between them, right? It says that if the says that force is directly proportional to charge Q1 and Q2, right? And is inversely proportional to distance r square. So electrostatic force is equal to K equal to Q1 times Q2 over r square. After we remove proportionality sign, okay, we'll give a constant, okay, this K, and this K is known as proportionality constant, okay, and where K is proportionality constant. So K equal to 1 over 4 pi epsilon naught, whose value is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square, okay, and the value of epsilon naught, okay, is 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square, and epsilon naught is known as permittivity of free space, okay, permittivity of free space. So after putting the value of K, the electrostatic force formula will become F equal to 1 over 4 pi epsilon naught Q1 times Q2 over r square, which is in air or in medium, okay. If the medium is not air or if the medium is not in vacuum, the electrostatic force formula will be different, okay. So it's saying that if the charge are placed in a medium other than a vacuum with permittivity epsilon equal to epsilon naught times epsilon r, then the formula will become F equal to 1 over 4 pi epsilon naught epsilon r Q1 Q2 over r square in other medium. Okay, where epsilon r is the relative permittivity or dielectric constant of the medium, okay. Okay guys, if you like my video, Please don't forget to subscribe and like my video. And and in next class we'll learn about Coulomb's law in vector form. Thank you guys.